You see, we are always trying to simplify things. That's the whole point. We are trying to simplifying this complex equation into one simple inequality. Can we do that? That's the whole purpose, right?
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning.
So there are two cases. If n is less than or equal to L, there is one case, and n is greater than or equal to L, there is another case. If n is less than or equal to L, we know both an and bn is less than or equal to L, right? And both of this bn is less than or equal to L. We know that in this case, maximum of a and bl will be less than or equal to maximum of L and L, that is L. If you know that in both the subjects, you will get 79 at max, you know the maximum score you can get is 79, right? So this is a very important concept. All of you understood this? I mean, let's take this case, the other case, because bn is already less than or equal to L. Now, if you have n is less than or equal, greater than or equal to L, so you have that maximum of an comma bn is less than or equal to what? It's nothing less than or equal to, but it's actually equal to an, right? Because L is greater than or equal to L and bn is less than L. So the maximum should be n because it's greater than L. Because an is less than or equal to, sorry, bn is less than or equal to L is less than or equal to an. And that's why you get this. And n is greater than or equal to bn. So the maximum will be n. So what we are getting? So we are getting that therefore there are two cases. We know that maximum of an comma bn is greater than or equal to an always, because maximum is always greater than or equal to any of the numbers, right? If an is less than or equal to L and maximum of an comma bn is equal to n if n is greater than or equal to L, right? So essentially, if you now take limit on both sides, it doesn't matter, because understand, if n is greater than or equal to L, maximum of n comma bn is equal to an, and that is included in this case. That maximum is of n comma bn is greater than or equal to an, that is included in this case. So this statement, maximum of n comma bn is less than or equal to L and greater than or equal to an, is always true. No, I'm so sorry. This is not always true, because no, no, it's not always true, because then less than or equal to L will be on the other hand side. So what you can understand is this, that you can see that whatever is the case, if you take limit on both hand sides now, you will get that here it's L and here also it's L. And in this case, you will also have limit n tends to infinity, max of n bn is equal to L. So you have both the limits equal to L, and hence in both the cases, and hence the Cn will be converging to L. Did you understand, guys? Yes or no? In both the cases. Now the question is that what if n is like up and down, up and down, up and down like this? What if in that case? The interesting aspect is that in that case, and so this needs a little bit of more mathematical justification. You understand, there's a, we cannot use any known theorem. It's like it's a bit of hand waving out here. The reason is this, and this is exactly the reason we need epsilon delta, right? The basic reason is that you may ask that, okay, I mean, how do you really make sure it converges? I mean, because it can be up and down like this. How do you make sure it converges? And that's where you see that. So we can do two things. So can we include both of them together into a single inequality for all the cases? That should be the criterion, right? We are trying to understand that only. So this is the entire inequality that we have. So let's see if we can mix both of this inequality into a same thing. If single inequality. And we know that max of n comma bn is, when it's greater than or equal to L, it's equal to n, like this. So can we include this in both of the inequalities? So the goal is, can we include both of this into a single inequality? Why we want to do this is the following, that we want to apply. So we understood this intuitively here, that in if n is less than equal to L, then in that space it is converging to L. And if n is greater than equal to L, then that space is also converging to L. If we take it together, it will both converge to L. But this is kind of a bit hand waving, you understand? So yeah, this is kind of a bit hand waving, and I do not want you to hand wave all the mathematics out there. So we want to understand that, can we include both of these inequalities together to form a single inequality, so that we can understand that that always happens. So we have to somehow manage this too. So understand that this is in case L is this, and this is in case N is greater than equal to L. So therefore, this is on the left hand side, it is nothing but always, so you can say this is less than equal to the minimum, nothing but the minimum of N comma L. On the right hand side is nothing but the maximum of N comma L. You see that always. If N is greater than equal to N, on the right hand side there is always L. On the left hand side there is always L. That means the minimum is always here and the maximum is always here. And here similarly, if N is less than equal to L, the maximum is L. So L is on the right hand side. So we can write both these inequalities together as maximum of An comma Bn is less than equal to max of An comma L and greater than equal to mean of An comma L. Did you understand this, guys? This is very important. We have combined both this. Otherwise, we have to do all the epsilon delta thing. That's not what we need, right? So therefore, we have got the max of An comma Bn is less than equal to this max of An comma L and mean of An comma L. Now, you know that An always converges to L. So the problem boils down to this, that if An converges to L, then does the minimum of An comma L also converge to L? And maximum of An comma N also converge to L? So therefore, the problem reduced down to a simpler problem now. That if we show that, now you understand the whole problem in full details, okay? There is no Bn now here. Now the question is that if An converges to L, it can be anything. Does the maximum and minimum also converge to L? That's the basic question. So let's see if we can do this without epsilon delta. I do not think so, because here the whole idea of epsilon delta comes in. And that's why you understand here at this point of time that we have not actually wasted time. We have understood this problem in a different dimension altogether. We have reduced this problem to a simpler problem. But probably this cannot be done by sandwich theorem, because there's only one single number out here. Okay, there's only one single sequence out here. We do not have multiple sequences. Two sequences are the N and minima of An comma L and max. So like essentially one sequence, input sequence. But for sandwich theorem, we need two input sequence, right? However, let's think about it. The inequality is the minimum of N comma L is less than equal to N and greater than equal to both N comma L and less greater than equal to maximum of N comma L. And again, that whole concept of if N is less than equal to N and N greater than equal to L comes in, right? If N is greater than equal to L, what will happen, and N less than equal to N, what will happen? But yeah, you can understand that. What you can understand from here is that minimum of N comma L, the limit of this is less than equal to L at most. And here you can understand the maximum of N comma L is greater than equal to L at most, right? And yes, because there is no upper hand thing to this. So we cannot directly use sandwich theorem out here, because you understand for sandwich theorem we need both a lower hand, an upper hand and a middle hand. So therefore, the problem boils down to the simple problem, which you can use it to solve the other problem. Also, the actual problem is that L is here again. This is L, and if we have, let's say, again, this kind of thing, then what will happen? That's the basic thing that we are trying to seek, right? Understand. So, and L is here. So we are seeing the maximum. You can see the maximum also converges, right? This is the maximum, right? The maximum also converges. Okay, here's an interesting thing. If you observe that there's a protrusion, so we are trying to understand it geometrically. So now, what is the length of this protrusion? You see, the length of this protrusion is nothing but, what is this? This is nothing but mod of an minus al, or rather an minus l, right, plus al. So, right, I'm just thinking of a new equation. What if you write like this, that so this max of an comma l is less than equal to the length of the protrusion, how much it's going above, plus the actual limit. So actual limit plus how much is going above or down. So the question is this true? The answer is yes.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.